So let's start. In this lecture, I will cover RDD. So let's start it. RDD. What is RDD? RDD is the basic unit which holds data in Spark. It's called RDD. So RDD, the full form of RDD is, let me write, resilient resilient distributed data set. And we have to understand what is resilient, what is distributed. Before that, I want to say one thing. The also RDD is a basic unit using which Spark hold the data. If you know the concept of block in HDFS, and using block, HDFS is storing data in worker node. Same thing Spark is doing. Spark is when Spark is loading some data from some location, and Spark is splitting data in form of RDD. So Spark is a RDD is a basic unit which holds the data in Spark. Okay, like block in the HDFS concept. And before that, I will try to write some pseudocode before going to. So how RDD code look like in Spark or Spark? So it will look like this: RDD1 sc dot text file. So let's think c.txt. Here loading some data here. Then on top of RDD1 we are try to do some mapping. RDD2 if you don't know. So RDD1 dot map. We are doing some map operation. If you don't know map, what is map operation, don't worry, I'll explain. Now don't try to understand this code symmetry. Just listen what I want to explain. Just listen carefully. Don't try to understand what is map, what is filter. We will go later in this topic. And now I am doing collect. I am calling in collect function. Let's think this is a function on map function, on filter function, on collect function, and on text file function. So that's how one Spark or Pysaprk code look like in our Pysaprk coding. So you know the this is you can see this is a text file on function, map each function, filter each function, and this individual function doing some operation. Okay, so there is one base RDD, and when we are loading some data, we are getting on RDD1. So this is a base RDD. Base RDD1 is a base RDD, and then we are doing some operation RDD2. Then we are doing operation and we are creating RDD3. Then just here we are just calling. We are doing some operation on top of RDD2, and we are getting this RDD3, and then we are calling this collect function. So see, this is base RDD. We are doing operation on top of base RDD here and creating RDD2, and here we are doing some operation on RDD2 and creating RDD3, and finally we are doing RDD3 dot collect. Why you are saying we are doing some operation? So in Spark there are two kind of operation. Okay, in Spark there is two. Listen carefully. This is important thing. Two kind of operation. When you're calling some function, it is doing some operation. So two kind of operation. One is transformation, one is action. Transformation. If I try to give you some example of transformation, that will be filter, map filter and text file function. If I give you example of action function, that will be count. Okay. What is transformation? What is action? Now I will explain you what is transformation. The main point in transformation is that transformation is lazy. Okay. So we don't have any specific definition for transformation, but the basic principle of transformation is transformation should be lazy. Why? So when doing sc.text file, this is one transformation. So you think when you are typing the sc.text file, immediately if you're writing this sc.text file in our Pysaprk console and only write this and hit our enter button, you will think that it will loading the you are thinking that it will load the text file. This is one transformation, but actually not. This is a transformation. But if we just write this line in our Spark console and hit our enter button, it will not immediately load the data from that path. It will actually load the data, but after some time, it will not immediately load the data. Why? Because Spark is lazy. We have to give signal to this our transformation to load the data. If you just write this data as a text file, so Spark engine will not load the data because transformation are lazy. Transformation will wait for action. I told you there is two operation. One is transformation, one is action. So when so now there we are doing some operation on RDD1, we're creating RDD2, then RDD3 here, RDD3. When we are writing this RDD3.collect, collect is one is action operation. Collect action operation is not lazy. When we are hitting this action operation, this collect function, Spark then try to load data from our system. When you hit this, when will our Spark engine read this statement, okay, I did this, I did it 3.collect. Then Spark engine will try to load data from our system from that path. Then Spark engine will do some operation on RDD1. It will produce RDD2. Then Spark engine will do some operation on RDD2. It will create RDD3. So Spark engine will wait for our action operation. To activate our transformation, we should have one action of operation in our code. So if we write this code, okay, and we are avoiding we write, if we write RDD1 this line, and we are not writing this line, and if we try to execute this code, it will not throw any error, but it will not do anything because we don't have any action operation in our code. Spark engine will try to find action operation because from this point Spark engine will start do our processing. It will wait for our operation function. Why? Because Spark is following some lazy evolution. So when we are using transformation, immediately transformation will not show some output. It will wait for action operation. So when, let me write that code again. RDD1 sc dot What is the SC? SC is a Spark context. Okay, it is a entry point to that Spark cluster. Okay, now if I load the data from a.txt, so it is a transformation. So transformation is lazy. So data will be loaded sometime later, but not now. It will wait for action operation. So data will be loaded sometime later, but not now, because transformation is lazy. Lazy. It will wait for action operation. Also, dd2 dd1 dot map. This is also transformation. It will not do. It will not do anything. It will wait for action. dd3 dd2 dd2 dot filter. It will not do anything because it is a transformation. And dd3 dot collect. Then when you are hitting this operation, collection is operation function. Sorry, when hitting this operation is a action. When Spark Engine will able to read this line action, then Spark Engine will try to start our processing from this line. It will read, it will load the data, it will do some operation, then it will show some output. And action is not a lazy. This is transformation is lazy, this is transformation is lazy. And in our Spark code we should have one action operation. If you don't have any action operation, Spark program will not give any output. That's how Spark work. Why Spark is working like this? And actually, do you think when you are calling this function, you are calling this transformation, actually it is not doing anything. It will not showing some output. It will not load data in our Spark cluster, but it is doing some minor thing. What is this? When you are calling this transformation, it is not it is not loading the data. When you are doing this map, it is not doing the map operation actually. In before, like when you are just writing this, it will not actually doing operation, but it is creating one DAG. DAG means direct acyclic graph. Because see, we are calling this sc.txt file. Okay. So Spark Engine will try to remember all those steps. What is happening before we are hitting action. Spark Engine, when we are hitting, when we are calling this sc.txt file. So what actually Spark Engine will do? It will create one diagram. So it will create one diagram. The diagram will look like this. Okay, it will look like this. We have to perform one loading operation. We have to load data. Then when you are writing this dd1 dot map, so Spark Engine will draw some diagram inside the Spark Engine, that is called direct acyclic graph, and it will at this I have to perform map. Then d2 dd2 dot filter. Then we are getting dd3 Spark Engine will write this step in this diagram, that I have to do filter operation. And now we are doing action operation. rdd3 dot collect. When Spark Engine hitting this action operation, when Spark Engine know that in this code there is an action operation, then it will try to look his DAG. It will try to see her DAG. That like when Spark Engine is hitting this function, it will try to look this DAG, and Spark Engine will execute step by step this operation. So Spark engine will look into this DAG and it will try to understand what what transformation I have to execute before this action operation. Then using this diagram, Spark engine will understand that I have to load the data from a.txt file. Then Spark engine will load the data. In this step, Spark engine will understand that I have to do this map operation on top of this RDD. Then Spark engine will do those map operation. In this step, Spark engine will understand that I have to do some filter operation. Then Spark engine will do filter operation. So it will wait for this operation. Before that, whatever transformation you are writing, those transformation will create one DAG operation, DAG diagram. And when are you hitting this I means action operation, Spark engine try to look into his DAG diagram, and from the DAG diagram, what steps mentioned there, like load, map, filter, those things Spark engine will perform those things. That's how internally Spark is working. So it will wait for action operation. Before that, whatever transformation we will doing, it will list it down in a file. See, this transformation I have to perform after getting action operation. Why is Spark engine waiting for this action operation? Because let's think in point of view of RDD. Okay, sorry, in big data. Let's think we have a file with 1 lakh rows. Okay, and we are just loading that file. Okay, RDD1 load file from HDFS. RDD2 we are doing some map operation. RDD1 dot map, RDD2 dot filter, and at the last we are doing RDD3 dot collect. See, if map is not if map is not lazy, like if the transformation is not lazy, so what will happen? Let's think I am not writing this line, I am not writing this action operation. Okay, so if transformation is not lazy, let's think that transformation is not lazy, then what will happen? So if you write this line, if you're loading this file, so if you write this file, this sc.text file and a.txt, like that path, it will load the data in our Spark engine. So that file will contain 10 lakh rows. Okay, this file is containing 10 lakh rows, and we are loaded that file in this RTD. And then I am doing some operation, transformation, map. Then I am doing some filtering here, that is also transformation. And at the end, we are not doing anything. We are just filtering data, but we are not saving this data. Okay, we are not collecting this data. Collect will give some output. Also, there is a function is called save, that will give some, that is also action, that will give some output. So what is I am trying to say, that we are doing some operation here, but at the end of the operation we are not trying to save the data. Then what is the meaning of doing this transformation? So is everybody will do like this? Everybody will load data? Sorry, everybody will load data in that Spark and do some transformation. Then they will abandon that code, that data. then it will be burdened, because it is not small data, it is a 10 lakh rows. It is a, it can be terabyte data, it can be 1 trillion data, like 1 TB, or then a TB, I don't know, like let's think 500 TB, 5000 TB data. So we are loaded that data and just doing some operation transformation and left it. Then that is the cost. Then the company will suffer, because we are loading huge data and we are not doing anything. At the end, we are not doing anything. We are not storing any result. Just we are doing less thing. We are doing. We are loaded two, and we are adding some two. We are adding three. Then like four, then seven, and we get seven. Then we are not saving that file, saving the data result. We are just abandoning it. Like, I got, like, then that is not the right thing, because in terms of data, we are in big data, there will be huge data. Okay, let's think 1000 terabyte data, we are loading it, and we are doing some map filter, then we are abandoning it. That is not the right thing. Okay, that will cost those big data company, like if that employee start doing this, it will load data and doing some filter map thing, then it will abandon it. It will cost huge money. It will be costlier for those companies. That's why Spark is saying, I will do those operation if I get our action. If I got any action operation, it means you are saving that result. Then you will try to execute your transformation. Before that, I am not doing. I just only create DAC, direct acyclic graph, to remember these steps. This that I have to load this data from this path. I have to do this operation. I have to do this filtering, mapping, and then if I get our action, I will try to do this thing from the DAC. Otherwise, it will not anything. So it will Spark engine wait for this action operation. Before that, it will only create DAC, nothing else. It will not actually load the file from those HDFS path. That's why Spark is lazy. That's why those developer created transformation as a lazy operation, or you can say Spark is lazy. That's why called Spark is a lazy evolution, because it will wait for action operation. Before that, it will not work, and it will create one diagram. When you will write our Spark code, there will be one diagram. There you can see which steps we have to perform. We have to, so there you can look like this. There will be one diagram look like this. This load, map, filter, until we are not getting action operation. The Spark engine will try to create diagram like this, and then when it will get some action operation, it will start executing our code from this stack diagram. That's why we call Spark is a Spark follows lazy evaluation. And one thing I want to say, that in that RDD, the full form. So this is the Spark follow lazy evaluation. It is completed now. Now we know the full form of RDD. RDD means resilient distributed dataset. What is the meaning of resilient? That I want to say. Now, resilient means fault tolerant. Okay. And if I created one DAC, and if you want to, like, if I also like this one thing I want to say, resilient means fault tolerant, and this distributed, I will try to explain later why it is distributed and why it is fault tolerance. Now I will explain. And there is a one concept called, like, every time you will try to understand RDD, they will say that RDD is immutable, and this resilient came from this immutable properties of RDD. Immutable. So RDD is immutable, and that's made RDD is a resilient. It means fault tolerant. This is the main reason why RDD is resilient. So why RDD is immutable? Why the Spark developer created RDD is immutable? What is the meaning of immutable? Once you load RDD with data cannot be changed. It means if I RDD1 sc.text file, then we cannot, if I loaded loaded some data in RDD1 variable, we cannot change that data again. Like we cannot do like this, the RDD1 equal to sc.text file again. We cannot do that. That is not allowable. Once you loaded data, you cannot change it. That's thing. Okay. So if I want to if I want to modify some data, you are thinking that I will do some this RDD1 dot map equal to RDD1. We cannot do this. Spark will not allow this, because once we created variable one RDD, we cannot change the data of that RDD. This is same concept in Python. Okay, in Python there is a concept called immutable. It is like same. Okay, we cannot change the value of RDD once it's created. Okay, if you want to do some operation on top of RDD1, that is possible. We are doing some operation on RDD1 and we are storing this operation value in another RDD. That is okay, but we cannot change, like we cannot reassign that value in same RDD. We cannot do like this. We cannot change RDD's value. Okay, once on RDD is created, we cannot change. And why they created RDD as a immutable? That one thing you have to understand. Why Spark the Spark developer designed it. It is like this. So one thing I will try to draw some diagram. So let's think RDD1. We are loading data here. RDD through RDD2, and we are doing filter T3 map and RDD3 collect. So let's understand. So we are doing some operation here, transformation here. We are doing some transformation. We are doing transformation here. Okay, this is the action. So let's understand. Let's try to imagine if our RDD2 is lost, what will happen? So we are created our DAC. We know that we have after RDD it will come RDD2, and then after doing some filter it will create RDD3. Then we are doing RDD3 dot collect. If this RDD2 is like it is lost, please understand it is lost, then what Spark will do? Okay, Spark will try to understand if my RDD2 is lost, Spark will refer this DAC and it will see that we are doing some filter operation on top of RDD to create RDD2, and that's how it will regenerate the value of RDD2. So if the RDD2 is lost from our memory, from our RAM, so Spark engine will refer this DAC and it will see we are doing in on top of RDD1. We are doing on top of RDD1, we're doing some filter operation to create RDD2. So it will do exactly the same. It will repeat that process. It will regenerate this RDD2, and that's how it's become fault tolerant. That's why the RDD is resilient. If some RDD is lost, we can recover it using DAC. So RDD can be recovered. RDD is fault tolerant as it can be recovered using DAC. So that's why DAC is important. We are noting down every step. If any step, any identity is lost, if this identity is lost, we will see that what is the steps to generate this identity1, identity2. So I have to perform filter operation on top of identity1. So it will do identity1 dot filter to create identity2. That's why we called identity is fault tolerant. And we know that every RDD is immutable. Like we cannot change the value of RDD. That's why it's make the Spark engine life easier, because let's think we are doing like this RDD1 loading some data, and RDD1 dot map RDD2, and then let's think RDD2 RDD2 dot filter RDD2 dot collect. So if RDD is not immutable, it means if RDD is, if we can change the value of data of RDD after creating RDD, if we can change the value of RDD, let's think that scenario. So we are loading that data and we created RDD1. Now let's think we are doing map operation and created RDD2, and we are doing map filter operation on top of this RDD2, and assigning same value on top of RDD2. Now my this RDD, this step is gone. This data is gone from our RAM. Then how we can recover? We cannot recover because we are reassigned some value here. So we cannot identify. We cannot separate this. We cannot. If we see our DAG also, we can understand that yeah, on top of RDD1 we are doing some map operation to generate RDD2. We can generate RDD2 here, but what will be next step? So this step will be also we have to regenerate. Then we are doing some reassigning on top of RDD2. So it will more complex. Okay, if it is not immutable, this fault tolerance will mess up. The Spark engine will mess up this fault tolerance ability. So if that RDD is not immutable, the fault tolerance of RDD will gone. So we cannot recover data if some data is lost. So we cannot recover RDD if some RDD is lost from our RAM or from our system. That's why these immutable properties of RDD is important. Immutable means we cannot change the value of RDD after it's created. After, if we created on RDD, we cannot change that value again. So summary is RDD is resilient. Resilient means RDD is fault tolerance. Fault tolerant. Immutable. And distributed. DD is fault tolerant. Resilient means fault tolerant, immutable, and distributed data set. So I already discussed about this fault tolerant, why it is fault tolerant, why it is immutable, what is the reason behind it. Now I'll try to explain you why it is distributed data set, why it is called a distributed data set. We'll try to visualize this distributed data set thing according one picture, and that will come in next video. So it is now 35 minutes. Now I will end this video here. Next video we will continue RDD and we will try to understand why it is distributed dataset. We will try to visualize RDD. We will draw some diagram. We will try to understand. Thanks.